Good. The audio is good. We'll get started. Good evening. This is the third edition of this year 2020 revision for class 10 CBSE math. We're doing chapter number 3, linear equations. This is a very important topic. Every year I've combed the question papers from 2016. Every single year, including the board papers as well as the sample question papers given, have had questions from this topic, from this chapter, a pair of linear equations in two variables. Conceptually, this is a very simple topic. Only two concepts to be covered, right? Unlike the earlier topics where we listed on quite a few concepts, here exactly two types of solutions to a pair of linear equations in two variables. Second, different algebraic methods to finding out solution to a pair of linear equations in two variables. So very straightforward. We'll quickly recap it, but we're going to be doing it with 8 questions, because though it's only two concepts that we are looking at, the questions that have been tested have come in multiple flavors. So I want to ensure that we are conversant with all of those that have been tested in the past. So if questions appear, not if, when questions appear from this topic, you are in good shape to crack all of them. Let's get started. I'm going to start with just ensuring that we know what the definition of a linear equation is. What's the definition of a linear equation? An equation which is of the form ax plus by plus c equals 0, where a, b and c are real numbers such that a and b are not both 0 is called a linear equation in two variable. Let's quickly do one thing. Let's write a typical example of such an equation. 3x plus 4y minus 12 equals 0 is an example of such an equation. Simplifying it, what is a linear equation in two variables? It needs to have two variables, x and y. The power of these two variables should be equal to 1. That's what is a linear equation in two variables. Now let's look at what do we mean by solution to such an equation. Here is what it reads. Each solution x comma y of a linear equation in two variables, something like this, ax plus by plus c equals 0, corresponds to a point on the line representing the equation. So obviously this equation represents a line. So here is a straight line and this is an equation that represents it. What does a solution to this actually mean? The solution to it is a point on this line. And it also says vice versa. What does it mean? A solution to this equation is a point on the line. A point on the line will be a solution to this equation. That's what it essentially means. Let's quickly find out a solution to this equation, right? Let's see if 4 comma 0 is a solution to it. Let's plug it in. 3 times 4 is a 12. 4 times 0 is a 0 minus 12 equals 0. It satisfies this equation. So 4 comma 0 is a point on this line. So 4 comma 0 is likely to be this point, 4 comma 0. It's on the x-axis. Let me try one more. Let me go with a 0 comma 3. 3 times 0 is a 0 plus 4 times 3 is a 12 minus 12 equals 0. So 0 comma 3 is another solution to it. There could be one more solution here, one more solution here. Any point on this line is going to be a solution to this equation. Any solution to this equation is going to be a point on the line. So now we know what a linear equation is. Now we know what a solution to the linear equation is. Now the concept 1 that we are going to be looking at is the types of solution that a pair of linear equations. Here we talked about one, then we're going to be talking about a pair of linear equations, something of this kind, right? The first equation is a1x plus b1y plus c1 equals 0. This is one linear equation. The second one is a2x plus b2y plus c2 equals 0. What all types of solutions can a pair of linear equations have? There are 3 variants that are possible. The first one is this. A pair of linear equations in two variables which has a unique solution. Exactly one value of x and y will satisfy these two equations is called a consistent pair of linear equations. This is the second variant. A pair of linear equations, it need not have a solution at all, which has no solution is called an inconsistent pair of linear equations. There's a third possibility. This is one solution, this is 0 solution, then there is a possibility of having infinitely many solutions. A pair of linear equations which are equivalent, we'll understand what this in a little while, not to worry right now, will have infinitely many distinct common solutions. Such a pair is called a dependent pair of linear equations in two variables. This is also a consistent system. This is also a consistent one. The second one is the inconsistent one. What are we going to look at it? We're going to pick these two equations. We're going to check out what will be the condition for the first situation. What's the condition for the second one? What's the condition to be satisfied for the third one? And we'll also check out what do they mean graphically. Let's start with the first one. If you have two straight lines, they could intersect at one point, as it happens in this diagram, in this graph. They may intersect at a single point. In that case, such a pair of linear equations will have a unique solution. Let's say this equation representing this line is a1x plus b1y plus c1 equals 0. And let's say the second line has an equation which is a2x plus b2y plus c2 equals 0. These two equations will intersect at one point and have a unique solution. When is that going to happen? That condition is this: a1 by a2 should not be equal to b1 by b2. Let's take an example, elucidate it, and then consolidate what do we mean by this graphically. Right? I'm going to take an example. 3x plus 4y plus 5 equals 0 is equation 1. Second one, let's take it as 4x plus 5y plus 6 equals 0. What is a1 by a2? a1 by a2 is a 3 upon 4. What is b1 by b2? That's a 4 upon 5. 3 upon 4 is not equal to 4 by 5. Therefore, this pair of linear equations will have a unique solution. They represent graphically, as you have seen already, a pair of straight lines that intersect at one point, or intersecting lines. So quickly, we'll have a unique solution, a consistent one, in the case when a1 by a2 is not equal to b1 by b2. Graphically, what it represents is a pair of intersecting lines. Let's look at the second scenario. This is a case where we have no solution. Obviously, you would have probably heard the saying, parallel lines never meet. Yeah, if you have a pair of parallel lines, they are not going to meet. So, if lines are parallel, in that case, because they don't have a meeting point at all, there is going to be no value, there is going to be no point that's common to both. Any solution to an equation is a point on the line. If you don't have a common point at all, there is going to be no common value which is going to be a solution to it, which is why it's called inconsistent. That is why it's called no solution. When is that going to happen? Equations are a1x plus b1y plus c1 equals 0. Second one is a2x plus b2y plus c2 equals 0. For a pair of linear equations which are parallel, what condition needs to be satisfied so that they have no solution? a1 by a2 should be equal to b1 by b2, and that should not be equal to c1 by c2. Here, let me pick an example to illustrate this. 3x plus 4y plus 5 equals 0. 6x plus 8y plus 15 is equal to 0. What is a1 by a2? That's a 3 by 6, which is equal to 1 by 2. What is b1 by b2? Which is 4 by 8, which is equal to 1 by 2. So, a1 by a2 is equal to b1 by b2. What is c1 by c2? That's a 5 by 15, which is equal to 1 by 3, which is not equal to what a1 by a2 or b1 by b2 was. So, this pair of linear equations will have no solution. What do they represent graphically? They represent a pair of parallel lines. Right? Quickly, to have no solution, a pair of linear equations has to satisfy this condition. a1 by a2 equals b1 by b2 is not equal to c1 by c2. Graphically, what does it represent? It represents a pair of parallel lines. Third scenario, when we're going to talk about infinitely many solutions. That could happen if the two straight lines are coincident. One lies flat on top of the other. In this case, the equations have infinitely many solutions. Any point on one line is going to be a point on the other one. It's called a dependent pair of equations, or they'll say one equation is the equivalent of the other. Let's quickly look at when is that going to happen. a1x plus b1y plus c1 equals 0 is one line. The second line also, which is lying on top of it, that equation is a2x plus b2y plus c2 equals 0. They will be coincident. They will have infinitely many solutions when this condition is satisfied. a1 by a2 equals b1 by b2 equals c1 by c2. Let's look at an example, something like 4x plus 5y plus 6 equals 0. 8x plus 10y plus 12 equals 0. So, a1 by a2 is a 4 upon 8, which is a 1 by 2. b1 by b2 is a 5 by 10, which is also 1 upon 2. c1 by c2 is a 6 upon 12, which is also equal to 1 by 2. So, 1 by 2, 1 by 2, 1 by 2, a1 by a2 equals b1 by b2 equals c1 by c2. Look at the second equation. Is it nothing but 2 times the first equation? That's why they said these are equivalent equations, dependent system of equations. So, for a pair of linear equations to have infinitely many solutions, the condition to be satisfied is this: a1 by a2 equals b1 by b2 equals c1 by c2. And what do they represent graphically? A pair of coincident lines, right? So, we know 3 things. Unique solution when a1 by a2 is not equal to b1 by b2. No solution, a1 by a2 equals b1 by b2 but is not equal to c1 by c2. Infinitely many solutions when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, right? So, concept number 1 done. Let's quickly look at how this is tested. Start with this question. On comparing these ratios, find out whether the lines representing these two linear equations, we've been given 2 parts, right? Do they intersect at a point? Are they parallel lines? Or are they coincident lines? Start with the first pair. 5x minus 4y plus 8 equals 0. So, a1 equals 5, b1 equals minus 4, c1 equals 8. In this equation, a2 equals 7, b2 equals 6 and c2 equals minus 9. So, let's find out these ratios. A1 by A2. A1 by A2 is a 5 by 7. B1 by B2 is a minus 4 by 6. And C1 by C2 is equal to 8 by minus 9. A1 by A2 is not equal to B1 by B2. 5 by 7 is obviously not going to be equal to a negative number. We don't even have to bother about what this is. If A1 by A2 is not equal to B1 by B2, then we are talking about a consistent system of linear equations. We are talking about a unique solution. We are talking about a pair of intersecting lines. That's what we are talking about. Quickly summarize this. We found out the ratios. The ratios are 5 by 7. In this case, it's reduced to a minus 2 by 3, and C1 by C2 is equal to minus 8 by 9. This is not equal. That's good enough. It doesn't matter whether this is equal or not. Obviously, we're not going to be worried about it. So because A1 by A2 is not equal to B1 by B2, we have a unique solution. They intersect at one point. This is a consistent system of linear equations. So move on to the second example. Part 2 in this has two equations. 4x plus 5y plus 10 equals 0. So A1 is 4, B1 is 5, C1 equals 10. Correspondingly, A2 is an 8, B2 equals 10, and C2 equals 20. Quickly find out A1 by A2, B1 by B2, C1 by C2. Pause the video at this stage probably, compute the answer, find out what kind of a solution, and then come back to the video. Did you do it? We'll quickly run through that here. A1 by A2 is a 4 upon 8, which is equal to 1 by 2. B1 by B2 is a 5 upon 10, which is also equal to 1 by 2. C1 by C2 is a 10 upon 20, which is also equal to 1 by 2. So 1 by 2 is equal to 1 by 2 is equal to 1 by 2. A1 by A2 equals B1 by B2 equals C1 by C2. So what are we talking about? We are talking about infinitely many solutions is what we are talking about. What kind of lines are these? These two lines are coincident lines. So one equation is the equivalent of the other. Second equation is 2 times the first equation. Summarize it in a printed form. We got A1 by A2 equals B1 by B2 is equal to C1 by C2. Therefore, infinitely many solutions, coincident lines is what we are talking about. Let's look at one more example. Which of the following pairs of linear equations are consistent or inconsistent? If they are consistent, obtain the solution graphically. They explicitly could state that you'll have to obtain the solution graphically. Let's look at it. Let's start with the first question. We're going to run through the same thing. We're going to find out A1 by A2, B1 by B2, C1 by C2. These are the values of A1, B1, C1. These are the values of A2, B2, C2. So A1 by A2 is a 3 by 6, which is equal to 1 by 2. B1 by B2 is a minus 4 by minus 8, which will reduce to a 1 by 2. C1 by C2 is an 8 by 9. So what do we have? A1 by A2 equals B1 by B2, but is not equal to C1 by C2, which means that we are talking about a case of no solution. We are talking about a case of inconsistent system of linear equations, pair of linear equations. So here we can't find the solution. So there's no point, no worries about finding the solution graphically. So first part done. Summarize it in a printed form. 1 by 2 equals 1 by 2, but not equal to 8 by 9. So we're talking about no solution, inconsistent system of equations. Let's look at the second part. X plus y minus 5 equals 0, 2x plus 2y minus 10 equals 0. So A1, B1, C1 are 1, 1 and minus 5. A2, B2, C2 are 2, 2 and minus 10. Let's find the ratios. A1 by A2 is a 1 by 2. B1 by B2 is 1 by 2. C1 by C2 is minus 5 by minus 10, which is also equal to 1 by 2. So we have A1 by A2 equals B1 by B2 equals C1 by C2. So we are going to talk about infinitely many solutions for it. This is going to be a case of coincident lines. So that's what algebra has left us, the conditions have left us. We'll actually check out whether they're coincident. We have the same, as in a set of values which are satisfying. We should have more than at least one value of x and y which satisfy both the equations, which means you're talking about 2. Then we can talk about many. We'll look at it. Let's get started. Summarize it in a printed form. A1 by A2 equals B1 by B2 equals C1 by C2. So this is what we have to discuss this. Now let's look at how to find out a solution to it graphically. Pick 2 points that will satisfy the first equation, right? The first equation is x plus y minus y equals 0. I'm going to tell you what are 2 good points. Always check out, if possible, it's going to make life really easy. A value when x is 0 and a value when y is 0. Essentially, graphically, we are talking about the intercepts on the x-axis and y-axis. If x is a 0, what is going to be the value of y? Y is equal to 5 minus 0, so y will be a 5. If y is a 0, 0 equals 5 minus x, which means x is equal to 5. So we've got 2 points. So all that I'm going to do, I'm going to pick this xy plane for the first line. This is going to be 0, 5. X-axis, x coordinate is 0, y coordinate is 5. So 0, 5. The second one is 5, 0. So 5, 0 is a point that satisfied it. So I'm going to connect these two. We have drawn the first line. Let's run through the same exercise for the second line. I'm going to start with x being a 0. When x is a 0, this term becomes 0. So 10 minus 0 by 2 is a 5. So 0 comma 5 is a point on the second line as well. I'm going to check out what happens when y is a 0. When y is a 0, 10 minus 2x by 2 equals 0. Cross multiply, we get 10 minus 2x equals 0 or 10 equals to x, which means x is equal to a 5. So 5 comma 0 is the second point. So 0 comma 5 is one solution, 5 comma 0 is another solution. So we have 2 points which are exactly the same 2 points relying on both these lines, which means these two lines are coincident. If you want, you can check out one more. Pick something like a 1 comma 4. Is 1 comma 4 going to satisfy this? 1 plus 4 minus 5 is a 0. Satisfies it. Let's check out whether it satisfies here. 2 times 1 is a 2. 2 times 4 is an 8. 2 plus 8 minus 10 will satisfy it. 1 comma 4 is a solution. 1.5 comma 3.5 is a solution. So it's got more than one solution. It can either be unique or it can be 0. Or it cannot have 2 solutions, 3 solutions. Then it can only have infinitely many. The moment you see that 2 solutions are there which are satisfying both the lines, then you can conclude that we are talking about coincident lines, infinitely many solutions, right? So we'll quickly run through it in a printed form. Looked at x0, then y is 5. y0, x is a 5. Same set of values satisfy the second equation too. We join them, got a pair of linear equations which represent coincident lines. This is how you get to the solution graphically. Let's move on. This is a question which again tests this concept a little differently. The pair of linear equations represented by these two equations, the coefficient of y is given as a variable. It's a k. You don't have a number there. This is going to be parallel if the value of k is what? When will a pair of linear equations will have no solution, or when will they be parallel? The condition to be satisfied is a1 by a2 equals b1 by b2 should not be equal to c1 by c2, right? Use this opportunity to completely recap all of these things. So let's quickly plug in the values. a1 by a2 is a 4 upon 8, which is equal to 1 by 2. This should be equal to b1 by b2, which is a 2 by k. Let's verify whether all of these three things are equal, right? This should not be equal to c1 by c2. What is c1 by c2 for us? 6 upon 11. 6 by 12 would have been a 1 by 2. 6 by 11 is not equal to. So this part is ensured. Now all that we need to do is basically solve this in between two values to find the value of k. Cross multiply, we'll get k is equal to 4. When k is 4, these two equations will represent a pair of parallel lines. Summarize it in a printed form. The two equations given to us are these. The condition for two lines to be parallel is a1 by a2 should be equal to b1 by b2, should not be equal to c1 by c2. We're plugging in values of a1, b1 c1, a2 b2 c2. Solving for it, a1 by a2 is essentially a 4 upon 8. b1 by b2 is a 2 upon k. This is 1 by 2. This should be equal to this. Cross multiply and solve. You get k is equal to 4. And quickly verify that this is not equal to 6 by 11. That's what we did in the earlier slide too. So this is what we have in a printed form. K equals 4. Right? So these kinds of questions have also appeared in the past year papers. Let's move on. When all was this concept tested? It was tested as part of the sample paper given for 2020, both in the basic version and in the standard version. Let's move on to the next concept. This concept 2 is finding out different algebraic methods to find solution to a pair of linear equations in two variables. Right? I've gone through papers since 2016. Not in one single paper have they mentioned the method that you need to use. Substitution method, elimination method are equally easy. I actually have a preference for elimination method. Cross multiplication is a little cumbersome. Don't go about it. They do not mention the method by which you'll have to find the solution. The last one is not a method actually in that sense. We have a pair of equations given which are not the typical pair of linear equations of the form a1x plus b1y plus c1 equals 0. We will bring those equations down to what is given to us to a pair of linear equations in two variables and solve it and find the answer. We're going to run through a few straightforward examples. We're going to look at an example for this. We're also going to solve a couple of word problems where information given to us has to be translated into equations and we'll have to find the answer. Right? Let's get cracking. Start with the first one. Here I'm going to solve it using substitution method. The question has not mentioned it, just to elucidate this method. These two equations are given. I'm going to write x in terms of y, picking the second equation. So x becomes y plus 4. In substitution method, what am I going to do? I'm going to plug in the value of x in the first equation as a y plus 4. We rewrote the second equation to get x in terms of y. We're taking that value of x in and we're going to substitute it in the first equation. So x becomes y plus 4 plus another y is equal to 14. Take the 4 to the right hand side, we'll get a 10. So you'll have 2y equals 10 or y is equal to 5. Substitute the value of y as 5 in one of these equations. Let's go to this equation. X plus 5 is equal to 14, which means x is equal to 14 minus 5, which is equal to 9. X is 9, y is 5 is the answer to this. Summarize it in a printed form, recap it once. We are rewriting the second equation as a y plus 4. Step 2, we are going to substitute y plus 4 as x as y plus 4 in the first equation. That's what you have done. This is x, translating to y to be equal to 5. Substitute the value of y as 5 in one of these equations. We are doing it in the first equation. So get the value of x to be equal to 9. Done with the substitution method. So move on to the second one. It's a number changed version of a question that appeared in the sample paper 2020. Quickly run through this. X plus y equals 4 is one equation. 2x minus 2y equals 4 is the second equation. So a pair of linear equations in two variables. Solve them algebraically and find the value of something called m which satisfies this equation y equals mx plus c. Let's get started. Let's try and equate the coefficients of y in both these equations. The coefficient of y here is 2. So if I multiply this with 2, if this is a plus 2, this is a minus 2, I can add and get rid of it. So I'm going to multiply the first equation with a 2. It will result in 2x plus 2y is equal to 8. The second equation is 2x minus 2y is equal to 4. Let's add these two equations. 2y minus 2y gets cancelled. 4x is equal to a 12, which means x is 12 by 4, which is equal to 3. Substitute that in the first equation. So x is a 3 plus y is equal to 4, which means y is equal to 1. So you found out x, you found out y. What we actually need to find out is m. Let's plug that in here. So y, which is 1, is equal to m times 3. X is a 3, this plus 7. So this becomes 3m. Take the 7 to the left hand side, becomes minus 7. 1 minus 7 is a minus 6. 3m equals minus 6. M is equal to minus 6 by 3, which is equal to minus 2. Quickly run through this, recap it in a printed form. These are the two equations. We are multiplying the first equation by a 2 so that the coefficient of y becomes the same. And then we are adding these two equations, gets cancelled. 4x equals 12 or x is equal to 3. Substituting the value of x as 3 in the first equation to get the value of y as 4. Plugging in the value of y as 1 and x as 3 in this equation to find the value of m to be equal to minus 2. Let's look at this. This is what I would call as a word problem or a condition given to us. It looks like a geometry question, but it's actually a linear equations question. The figure given below, ABCD is a rectangle. Rectangle creep property, opposite sides are equal, opposite sides are parallel. So if one of the sides measures 26, the other side will also measure 26, whatever we have written about it. So the first equation for us, therefore, is 2x plus y equals 26. The second equation is the width is also going to be the same on both sides. X minus 3y is the width mentioned on one side. 6 is the width mentioned on the second side. Let's figure a way to make the coefficients of y the same in both these equations. I'm going to go about it using elimination method. So let's multiply this equation with a 3. So that will result in 6x plus 3y is equal to a 78. Second equation is x minus 3y is equal to 6. Let's add these two equations. 3y and minus 3y gets cancelled. 7x equals 84 or the value of x is equal to 12. Substitute the value of x as 12 in one of these equations. Let's do it here. 12 minus 3y is equal to 6. Take the 3y to the right hand side. Take the 6 to the left hand side. 3y equals 6 or y is equal to 2. So what we have to find out? We needed to find out the values of x and y. X equals 12, y equals 2 is the answer. Summarize it in a printed form. ABCD is a rectangle, so opposite sides are equal, which means x minus 3y, which is what is mentioned in one side, is equal to 6, the width. 2x plus y is the length mentioned on one side, 26 is the length mentioned on the other side. We're going to be solving this by multiplying the second equation with a 3. This is what it is resulted in. Adding these two to find the value of x as a 12, substituting that in one of the equations to find the value of y as a 2. Let's move to the next one. Here we got one more side to this polygon. It's a pentagon. ABCD is a pentagon. Its perimeter is 24, which means sum of all of its sides is 24. So AB plus BC plus CD plus DE plus EA, this is going to be equal to 24. We need to find the value of x. Let's plug in. AB is an x plus y, BC is an x minus y, CD is a 5, DE is a 6, EA is a 5. This is equal to 24. I'm going to club all of these first. This is 10 plus 6, 16. So on the right hand side, it's going to become 24 minus 16. You've taken all of this to the right hand side. Y and minus y will get cancelled to leave us with 2x on the left hand side. 2x is equal to 8, x is equal to 4, which is what we needed to find. Quickly run through it in a printed form. Perimeter of the pentagon equals 24, which is sum of all of these sides. Substituting values which are given and variables which have been mentioned. Y and y gets cancelled to leave us with 2x. This goes off. This addition is equal to 16. So 2x is equal to 8, x is equal to 4. Lastly, this is the one where I said pair of equations that will reduce to a pair of linear equations in two variables, and then we'll solve it. Right? The equations given are 1 by 2x plus 1 by 3y equals 2, and 1 by 3x plus 1 by 2y equals 13 by 6. Let's get started. What I'm going to do is I'm going to rewrite these equations, splitting the denominator of this variable in this each of these expressions into two parts. 1 by 2x, I'm going to write it as 1 by 2 times 1 by x. That's what I'm going to do. So we've done that. So this is the equation that we have. 1 by 3 times 1 by y, that's equal to 2. 1 by 3 times 1 by x, which is 1 by 3x. 1 by 2 times 1 by y, this is equal to 13 by 6. Now we'll reduce it to a pair of linear equations the way we are used to seeing it. Something like a 4x plus 5y equals 7 is what we know as a typical linear equation. So I'm going to take this 1 by x and replace it with a p. I'm going to assign p as 1 by x. And 1 by y is equal to q. So wherever you see a 1 by x, replace it with a p. And wherever you see a 1 by y, replace it with a q. So it's going to be half p, which I'm going to write it as a p by 2. And this is going to be 1/3 q. We can write it as a q by 3. This is equal to 2. Let's come to this equation, second equation in a while. I'm going to take 6 as the common denominator. It's the LCM of both these denominators. So this is going to become 3p plus 2q. This is equal to 2. Cross multiply. So we have 3p plus 2q is equal to 12. Let me call this equation as equation number 3. I'm going to run through the same exercise here. This is going to be a 1 by 3p, which is going to be p by 3. 1 by 2q, which is going to be q by 2. This is equal to 13 by 6. Again, let's take the common denominator for the left hand side, which is the LCM of 3 and 2, which is a 6. So we'll get 2p plus 3q. This is equal to 13 upon 6. Cross multiply this. 6 and 6 will get cancelled to leave us with 2p plus 3q is equal to a 13. This is equation number 4. Summarized till this point, this is where we have reduced this equation to a pair of linear equations. Look at these two. These are the equations that we're used to looking at as a pair of linear equations, right? Summarize it in a printed form. We've taken p to be a 1 by x, q to be a 1 by y, substituted it here. So this is the first equation and this is the second equation. This equation gets rewritten as 3p plus 2q equals 12 by taking 6 as a common denominator. Same 6 as a common denominator will leave us with this as the equation. Now we expressed it as equations which we are used to looking at it. I'm going to solve it two ways. One, straightforward textbook elimination method in the printed version. This is a lovely set of equations. I want to walk you through an alternative method to help you understand how to solve if you encounter this. These are very easy ways to solve it. Look at it. The coefficient of p is the coefficient of q in the second equation. Coefficient of q in the first equation is the coefficient of p in the second one. If you find such equations, first step, add the two equations, 3 plus 4. I'm going to add it. So that will leave us with 3p plus 2p, which is 5p. 2q plus 3q, which is equal to 5q. This is 12 plus 13, which is a 25. So we end up getting p plus q is equal to 5. Let's call this as equation 5. Let's subtract equation 4 from 3. 3 minus 4. 3p minus 2p will leave me with a p. 2q minus 3q is going to leave me with a minus q. 12 minus 13 is a minus 1. Let's call this as equation 6. These are lovely equations to solve, very easy ones to solve. Add these two, q and minus q get cancelled. We're left with 2p is equal to a 4 or p is equal to 2. Substitute the value of p as 2 in one of these equations. So 2 plus q is equal to a 5, which means q is equal to 3. Now what is p? P is 1 by x. So 1 by x equals 2, which means the value of x is going to be equal to 1 by 2. What is q? Q is equal to 1 by y. 1 by y is a 3, which means y is equal to 1 upon 3, right? Done. This is all that it takes. Quickly summarize it in a printed form. As I mentioned, I've used one method here. I'm going to use a different method, which is a classic textbook elimination method to solve it in the printed version. These are the two equations that we're trying to solve. I'm going to equate the coefficient of p in both these equations. So multiply the first equation with a 2, multiply the second equation with a 3. So this is what you're going to end up with. So coefficient of p equated. So this is 6p plus 4q equals 24, 6p plus 9q equals 39. Subtract equation 5 from equation 6. So what you're going to end up getting, or we have done 6 minus 5. Minus 5q equals minus 15 or q equals 3. So these two get cancelled. Minus 5q equals minus 15. Q is equal to 3. Plug it in one of these equations. Find the value of p to be equal to a 2. This is 1 by x. This is 1 by y. So you can find out the value of y as 1 by 3 and x as 1 by 2. Right. So this summarizes all the different questions that appear, that have been tested in different years. When all did we get questions testing these linear equations as a concept, either in terms of a rectangle or a pentagon or word problems or equations reducible? These were all the questions that appeared, right? In 2018 and 19 in the board exam, 2019 sample paper, 2020 basic version. In fact, in 2020 standard version, the 29th question had 2 internal choices. Both the choices basically tested this. When is the next session? As usual, Thursday, 13th February at 7 p.m. We're going to be looking at quadratic equations. Again, a lovely topic. We're going to run through that from 7. Probably will go on for half an hour, 45 minutes. That should help you recap that topic. Inform your friends about this channel, youtube.com/Maxtute. Ask them to subscribe to it. Visit us every Thursday, every Monday till the board exam. We'll be recapping one topic after the other. Best wishes for your board preparation.